Dear students, welcome back to our family of quadrilaterals. In this spirit, we will solve a few more questions related to the properties of parallelogram. Let us see the question. Show that if the diagonals of a quadrilateral are equal, and they are bisected each other at right angles. So we are given three conditions. Diagonals are equal, they are bisected, and they are meeting at 90 degrees. Then we have to show that it is a square. So for that, we have to prove in three parts. First, we have to show that ABCD is a parallelogram. To show this is a parallelogram, let us take the triangle AOD and BOC. Why we take these triangles? Because we have to show that one pair of opposite sides are equal and parallel. Then this quadrilateral will become a parallelogram. So that's what we have to prove now. First, to prove ABCD is a parallelogram. For that, let us take the triangle AOD and BOC. So in triangle AOD and triangle COB, we can see that AO is equal to OC and BO is equal to OD. The reason is both of them are, first they gave you the diagonals are equal and they are bisected. Which means, for example, AC is 20 centimeters, BD is also 20. It is bisected, which means AO is 10, CO is 10, OB is 10, OD is 10. All of the sides will be equal. So we get two sides here, S and S. And now we know that angle AOD is equal to angle COB because they are vertically opposite angles. Angle AOD is equal to angle COB, vertical angles. So by side, angle, side. By SAS, triangle AOD is congruent to triangle COB. So from here, we get the side AD is equal to BC because they are corresponding parts. Look at the position. Therefore, AD is equal to CB. Corresponding parts of congruent triangles are equal. And another part that we get equal is angle ADO. ADO is equal to CBO. ADO is this angle is equal to this angle. Angle ADO is equal to angle CBO, corresponding parts of congruent triangles. But what did we get now? We get alternate interior angles are equal, which means these two sides are parallel. Therefore, AD is parallel to BC because alternate interior angles are equal. So finally, we get one pair of opposite sides are equal and parallel. So ABCD is a parallelogram. ABCD, because one pair of opposite sides are parallel and equal. So we prove that ABCD is a parallelogram. Next step to show that ABCD is a square is we have to show that adjacent sides are equal. For that, let's take case 2. Here we are going to prove that AB is equal to BC. To prove AB is equal to BC in the parallelogram ABCD, because just now we have proved that ABCD is a parallelogram. For that, we have to take two triangles which has these two as the sides. So the triangle AOB and COB. In triangle AOB, we can see that AO is equal to CO. Equal diagonals are bisected, given. Also, we have BO is common. So we get another side now. And AOB is equal to COB is equal to 90 degrees because they are right angles. Angle AOB is equal to angle COB. It's given. They meet at 90 degrees. It's given to us. So by side, angle, side. So by SAS, these two triangles are congruent again. AOB is congruent to triangle COB. Thus, we can prove that side AB is equal to BC by corresponding parts of congruent triangles. So we prove the second part now. AB is equal to BC. So we get the condition that ABCD is a parallelogram with two adjacent sides are equal. Now the last condition to prove that it is a square is that one of the angle is 90 degrees at least. So let us take the next case to show that at least one of the angle, let's say angle D is equal to 90 degrees. This is to prove. For that, we have to take two angles. For that, we have to take two triangles in which one of them has the whole angle D. The whole angle D is in the triangle, let's say ADC. So let us take the triangle ADC and BCD. In triangle ADC and triangle BCD, we know that BC is equal to AD because they are the opposite sides of a parallelogram. And it's given BD is equal to AD. Diagonals are equal. BD is equal to AC. Diagonals are equal. Also, CD is common. So we get all the three sides from both the triangles. So by SSS congruence rule, we can see that triangle ADC is congruent to triangle BCD. And when two triangles are congruent by CPCT, we get angle ADC is equal to angle BCD. So we found that these two angles are equal. But we know this shape is a parallelogram. In a pair of parallel sides, we can apply same side interior angle is 180 degrees. Angle D plus angle C is equal to 180 degrees. Same side interior angles. Are supplementary. That was a rule that we, or theorem that we studied in previous chapter. But both of them are equal, so we can say two angle D is 180 degrees or angle D is 90 degrees. So if one of the angle is 90 degrees, we can see all of the angles are 90 degrees in a parallelogram because the opposite angles are equal. So if this is 90, also 90. If this is 90, angle A is also 90 degrees. Hence, ABCD is a square. Therefore, ABCD is a square. Once again, a quick review. To show that a quadrilateral is a square, we have to consider three parts. First one is to show that ABCD is a parallelogram. Because the diagonals are equal and they are bisected, it is easy to show that it is a parallelogram by considering two opposite triangles. When we have to show that adjacent sides are equal by taking two adjacent triangles, so we will get two sides are equal. And finally, we have to show that at least one of the angle is 90 degree, then the whole ABCD will change to be a square. So let us see the next question. Diagonal AC of a parallelogram ABCD bisects angle A. So condition is ABCD is a parallelogram and the diagonal AC is bisecting angle A. So let's say this is angle A and this is also angle A. Because this is a parallelogram, we can apply the alternate interior angles. So angle DCA is also the same as angle CAB. So let us say angle DCA is equal to angle BAC because alternate interior angles. Between the sides AB parallel to DC. Also, we can find that AD is parallel to BC. AD is parallel to BC will let us take the alternate interior angle. If this angle is A, this will also be A. Angle DAC is equal to BCA. Same reason, here AD parallel to BC. AD parallel to BC. So it's clear that AC bisects, therefore AC bisects angle C because both of them are equal. From, let's call this as equation 1 and equation 2. From 1 and 2. Next, we have to show that ABCD is a rhombus. From the triangle ABC or in triangle ABC, we can see that two base angles are equal. Can you guess what was the property if the base angles are equal? Amazing. If the base angles are equal, then the opposite sides are equal by isosceles property. Side AB is equal to side BC because angle BAC is equal to angle BCA. We apply isosceles property or isosceles triangles. So we found these two sides are equal. In a parallelogram, if adjacent sides are equal, then it is a rhombus. Therefore, ABCD is a rhombus because adjacent sides of a parallelogram are equal. Great. Let's move on to another example. ABCD is a rhombus, means all sides are equal. That's what we are given first of all. We have to show that diagonal AC bisects angle A. We have to show these two angles are equal. And first of all, it's given that ABCD is a rhombus. So in a rhombus, opposite sides are parallel. Alternate interior angles. So if this is A, that's also A. So we can say angle DAC is equal to angle BCA because AD is parallel to BC, alternate interior angles. Same way, but we know that AD is equal to DC. Because it is a rhombus, all sides are equal. Now, from the triangle ADC, it is isosceles now. So we can say that angle DAC is equal to angle DCA. So this will also be equal to A because it is isosceles triangle. And by considering CD parallel to AB, we get that this is also A. Also, angle DCA, by considering these two sides are parallel, we can apply the alternate interior angles. So these two are equal. Angle DCA is equal to angle BAC. By considering AB parallel to CD, again alternate interior angles. So from the shape, it's clear AC is bisecting angle A as well as angle C. Therefore, AC bisects angle A and angle C. Similarly, if you join BD, we can find that BD bisects. Similarly, when we join BD, we can see that BD bisects angle B and angle D. That's what we have to prove. Well, moving on to question 8. ABCD is a rectangle in which AC bisects angle A as well as angle C. So this is bisected. They gave you it's bisected. So we can say, let's say this is A and A. And it is a rectangle, so opposite sides are parallel. So if this is A, by following the Z shape, this is A, this is also A. So all these four angles are equal. First, we have to show that ABCD is a square. To show that a rectangle is a square, we just have to show that adjacent sides are equal. So to prove AD is equal to DC, any two adjacent sides. For that, in triangle ADC, see, the base angles are equal. So the opposite sides will be equal. Since angle DAC is equal to angle DCA, AD is equal to DC because isosceles triangles or isosceles triangle property. So if adjacent sides are equal, it is a square. Since adjacent sides are equal, ABCD is a square. Do you wonder, like, why don't we show the other sides? It's obvious because look at this one. In a rectangle, opposite sides are equal. AD is already equal to BC. But now we prove that AD is equal to DC. And DC is already equal to AB. So AD is equal to DC, and which is equal to BC, which is equal to AB. So all sides are equal, and it will be, each angle will be 90 degrees because it's a rectangle. So each angle is 90, so it is a square. Now the last part we have to prove is diagonal BD bisects angle B and D. So let us join BD. We have to show that it is bisecting angle B as well as angle D. In triangle ABD, AD is equal to AB because it is a square. In a square, all sides are equal. So if these two sides are equal, the angles will be equal. So let us consider this is B, that is also B. Therefore, angle ABD is equal to angle ADB. Isosceles triangle property. So we get these two angles are equal. Let us name B. But we know that alternate interior angles are equal because AD is parallel to BC. So, but angle ADB is equal to angle CBD, alternate interior angles. So this is also B. Again, you know that AB is parallel to DC, so that's also B. Therefore, angle B and angle D are bisected by BD. So what do we understand? In a rectangle, if one diagonal bisects one of the angles, that shape changes to be a square. And also, all the angles around that diagonal will be equal. So each of the angle will be 45 degree because it is bisected. In the beginning, it was 90 degree. It is bisected, which means all the 8 angles in the square will be 45 degree each. Hope things are clear, and we will continue with a few more questions in the next period. That's all for today. Thanks for watching.